Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. Today, we have some topics around a little bit of like hardware attacks, as well as some web issues, of course. But before we get into that, we have a bit of a fun bug that was introduced by Z. So I'll let him talk about that and go on a bit of a storytelling adventure here.
Yeah, we get to cover a bug that, I introduced today. It's not a super exploitable bug here. Or there is perhaps a remote exploitation ability with this. It's an out of bounds read. I've talked about a bit. I've been working on like Minecraft stuff, and one of the projects I've kind of taken on is there's this tool that exists to kind of get you from, you can give it like coordinates in game, be like, go to this place, and it's just going to get you there. And it has this cool feature where in the game you've kind of got this thing called a elytra where you can fly. And it has like its own physics for how you fly around and all of that. And so there's an existing project that will fly in only one of the game's kind of worlds or dimensions. And I just want to make it work everywhere, so you can use it to fly anywhere in the game instead of just in this one area where, frankly, it is more useful in the area that they did it. Like, it makes sense why that project only focused on one area.
Yeah, that's in the Nether for anyone that's curious. It's the
Yeah,
Nether Pathfinder. Yeah.
it'll pathfind through the nether dimension of the game. And, the pathfinding in that case is important to make it work in, like, the overworld. You don't have to pathfind as much. You just go really high in the sky and you can fly a straight line. So, like, the effort isn't as important there because there are easier ways to kind of go about it. But I wanted to patch the program to get it working with just having it work kind of universally everywhere, because they did write some other code that works with this code that works very nicely for kind of flight control that I want to take advantage of. Anyway, so I set about trying to expand. The big difference is like they were only tracking like a height of 128, and in these other areas it jumps up to 384. So like it has this bigger area. So in testing, seeing like, can I get this to work in the first place before I tried to do a PR? I went and changed the value in both reading a file and some other places to just look for 384. It would just read from 0 to 384 in this file and just iterate that. And then came back later and I actually introduced like dimensions, and they would pass in a buffer of the appropriate size for each dimension. But I forgot to update this 384. So even if you passed it in a smaller buffer, it was still fixed to go and write 384. So a very stupid mistake on my side, one that we have called out endless times before on the podcast. And even worse is the fact that, this would be caught by address sanitizer. And this is kind of I think the interesting aspect to this is, why didn't my address sanitizer pick this up for me? Because I would build this with ASAN, and ASAN does pick it up. So, it was there, it never came up, so I just forgot about this one internal function and, create a problem. So what was going on is, I kind of have two issues with this. One is just, like, obviously performance and pathfinding, which I didn't need to worry about a ton. It's doing A star, so, and they've got optimizations around, like, how they're doing that, how they're finding the empty blocks and all of that's, like, that's pretty solid already. And then just kind of memory management questions. I took a very naive approach in my first stab at it, did something else, and that's kind of where we've been with getting it going. But I was testing this code and just like, I would write it, I want to find the overworld dimension. So I would write some code and then I'd go and try it in the overworld dimension. So it was always working with 384 when I would test it. But I would run some tests on the other chunks, on the other like file sizes. The problem is when I would run those tests, I would also be like, okay, well, if I'm going to go run that test, I'm going to go ahead and check the memory usage, see how much memory we're using here versus the other places. And those builds, if you're familiar with ASAN, ASAN is a memory hog. Like, it takes a bunch of virtual memory. It doesn't actually.
Yeah, because it needs to allocate the shadow mapping and everything.
Yeah, so it takes like a ton of memory there. So it kind of messes with my attempts to look at what's the memory usage look like. So every time I would actually run the test where ASAN would have picked this up, I was disabling ASAN. Um, I just think that's kind of a fun side effect here. Is yeah, I had ASAN on there. I was testing with it, but for the test cases where it actually mattered, it just slipped right through. A very easy bug. Obviously, I'm aware of the security consequences of it. And in this case, like this file that we're reading is a local file. We're running this as the same user, so there's no privesc in that sense. But it is based off of the server's chunk information, so like the world that was generated by the server. So in theory, you could have a malicious server generate a malicious chunk that you then try and pathfind through with this that leads to the overread.
That would be a little bit of an insane attack scenario, but
It would
yeah.
be a very insane attack, especially because this is an overread. Although, no, I guess, let me think about this actually in terms of the exploitation. So, no, I guess we're reading too far, but then we do try and set the bits in it. No, sorry. Because the bits are being written into a different structure that is always 384. That was one of the changes there. Like the base size of the structures now are 384. It's just the file read would be going out of bounds. So yeah, I mean, there would be like, I can't see this like even so. This didn't even make. This is still in like a separate branch for testing this. It's not like it even hit live code that anybody would maybe be using. It's in a version when he's using it at that, or isn't really being used. So yeah, it's not like it landed in live or something, but it is. I thought it was an interesting case because of the fact, like, ASAN should have caught this and could have caught this had I not been turning off ASAN at just the wrong moment, and when I'd be switching files to test this one other case where everything else looks fine. So I'm like, okay, turn it off and do this other test. And so that little bit I thought was kind of the interesting part of this, just how the bug kind of slipped through there.
I think it's a good example of the consequences you can have of trying to test multiple things at once. The developer mindset in you kind of wants to be like, okay, I want to be efficient. I want to make the most of my time. So I'm just going to test a couple things while I'm doing this. And when you have that case where trying to test one thing conflicts with the other because of, having to reduce the memory overhead of turning SAN off, that's how you can run into those problems. And like it's a totally excusable error to make. Like I understand wanting to, like, testing things, especially in games, is very annoying. I don't want to do it more than I have to. So like trying to test multiple things in the same instance, like I totally understand, but it can lead to problems.
Yeah, and I think part of this also, like, I might have kind of cued in to the fact that I had the 384 there, but that is like the actual write is happening in that structure that is 384 big. The actual write itself is okay. It like to go that long. It's just the read I wasn't necessarily thinking of. But I think like, okay, well it's this size, so I don't need to worry about the actual size. Like, yeah, it is a little bit of a weird place for it to happen too, having that. But yeah, I don't know. The ASAN aspect, it kind of got me when this bug got pointed out to me. It's like, yep, that I know exactly how I did that.
Just think, if Nether Pathfinder was written in Rust, you wouldn't have had this problem.
If it was written in Rust, I probably wouldn't have even. I guess I probably would have still tried because this is written in C++. This code looks all right here, but there is code in here that I don't get.
Yeah,
the other guy that
like, nah.
The other guy that
like
rewrote some of the stuff I put on here clearly has a much better handle when it comes to the generics and templating and everything, and just completely took care of a lot of the issues that I was also really surprised by overhead on array access. I did one thing. I'm thinking like, oh, this, I mean, it's an abstraction over this, but like, it's not that bad. It's ultimately, this should compile down to like a LEA instruction. Like it's whatever. Turns out it's like, a 20x performance hit because of how C++ does because all your operators are like actual functions. So this array access, instead of being an LEA, ends up being like some massive thing that actually it wasn't a noticeable performance hit in practice, but like in benchmarking, it was a very real hit that I just kind of assumed, oh, this is fine. And it wasn't. See, I learned some stuff about C++ in this, but I'm not excited to do any more C++ work.
I have a little bit of like exposure to that just because of some people I've talked to that work in game development. And that's actually a huge thing with C++ is they avoid the standard library like the plague. They always roll like optimized libraries for like containers and like arrays and all that stuff because the standard ones especially are so inefficient for array accesses that it's a big problem in game engines, which surprised me a
I
little bit
believe
too when
it.
I heard about it. Yeah.
Yeah, like I was trying to benchmark it a bit, and I did notice I could, in some cases, actually get it to optimize down, like with O3. In some call cases, so like inlining the right things, it did actually optimize it out to an L3, but I couldn't even get that consistently. Like I couldn't even get to a point where I could like get a benchmark that like, yeah, see, like it works. Like no, I couldn't even get to that point. So yeah, I was just surprised by that. Like it is one of those things that, if you work in C++, you're probably well aware of those performance aspects. Obviously, I look at things a lot more from a security perspective, so not necessarily
You're not really like
performance.
profiling performance, yeah.
Yeah. Yeah, so I'm not excited to do any more C++ work, and if this were in Rust, yeah, I don't know how I would have reacted. I think I still probably would have given it a shot to jump in on this, but
Yeah, I mean that is one thing. Like I was just kind of joking about it, but I find
yeah.
it personally very difficult to hack on Rust code bases compared to others. And that's
But sorry, go ahead.
I was just gonna say that's mostly just due to my lack of comfortability with Rust. But reading Rust code, like you have that kind of thing with languages where if you know a couple languages, for the most part, you can read a lot of other languages pretty easily. Maybe you can't write it very well, but you can understand what the code is doing. In a fair amount of cases with complex Rust code bases, I don't even really know like what a particular line of code is doing because of the weird like uh context you can have with all these different symbols and changing the meaning of things, and it can get very complicated, so I understand that completely.
Yeah, Rust has like one, some of the symbols and like just the operators aren't exactly clear, like if you haven't worked with them before. And two, it also just like it has a different paradigm going on with some of the operators it has. Like it does have a bit more
Yeah.
of a functional feel. Whereas if you go learn like Java or something, you're learning a lot more of an imperative paradigm language. And so you can
Yeah.
work with other imperative languages. And Rust is still, technically, I'm pretty sure it's still imperative, but like, that difference is there. And I also just find with Rust, like reading other people's Rust is just, more challenging, I think. Again, could be related, like I said, with the comfort level in Rust, but it's just, I don't know, maybe it is just lack of familiar with all the Rust isms, but that does kind of feel like a thing where it's not as, like, if you read Python, you've got a lot of Pythonic statements or things are kind of done in one way in particular. And I'm not sure if that's really the case with the Rust. Like Rust definitely has some kind of standard ways of doing things.
But there are a lot of different ways you can do things as well. That is
Yeah,
something I've struggled with. Yeah.
yeah, I don't know. Maybe I need to read more Rust code though to get a good feel for if people kind of follow conventions a lot or not, especially in the larger projects. But that is kind of a thing I've noticed with Rust is that other people's Rust code, I don't necessarily understand what they're trying to do, like what convention they're trying to follow. Like obviously they have something in their head that they're following. It's just whether or not I'm understanding it.
But yeah, I mean that was a bit of a tangent, mostly joking there, but still, I mean like it's a great example of the kinds of traps you can fall into, even though the impact here wasn't really higher at all or anything. Um, again, like we kind of talked about it recently, but that developer versus security mindset you get into, uh, you can have that conflict and easily skip over things. So
Yeah.
I will say, by the way, is the address sanitization part of like the standard? Well, I guess it would be, right, because that's how they caught this issue. I'm a little like I'm kind of
Oh,
impressed that's part of the.
I don't know if the other guy I'm working with or who's been on the PR, at least Bob and Jay. I don't know if I'm even saying his name right. I don't know if he caught it with ASAN. I just know it was catchable with ASAN. He might just recognize it when he
Oh,
jumped in the
sorry.
code.
Okay, yeah. Yeah, I was just looking at the commit. I thought they mentioned ASAN, but no, that was you that was talking about that. Because I was gonna say like having a SAN in the process for a a project like this, like that would be pretty impressive. There's a lot of like production processes that don't even have address sanitization or instrumentation in the pipeline. But
Yeah, so it doesn't make it to Minecraft. I'm not running this in Minecraft. I can't even get a build going in Minecraft with debugging symbols. So even like
yeah,
crash logs there. So no, there'd be a separate program that I would be compiling to just make the calls directly, because it is a library ultimately. That's called like JNI.
makes sense. Yeah.
So in those cases, I was just building a binary that would have ASAN on the entire chain, and that's where I would
Okay.
need to test with ASAN. Not in the actual game. Actual game, I actually the whole build system I had to use Auth, if you're familiar with that tool, in order to build this because I couldn't do it manually. And that the thing
That
is
sounds like
with
a lot of fun.
building mods, there's a lot of kind of extra effort that goes into building a jar that can be taken into another like or into another like Java process and stuff. Like it's a whole thing that I actually don't understand the process on.
Yeah, I don't have a lot of visibility into that either. I've played Minecraft, I've played some mods, but I've never really looked into how to write them. So I was a little bit curious on like what the testing practices and stuff of that were. But yeah, it's not something I've really looked into.
Yeah. So yeah, like for testing with sanitizers, it was just because it's just a CMake project, so like it's easy enough to add the flags in when you want them.
Yeah,
But yeah, it doesn't make its way all the way into the mod itself.
fair enough. All right, but yeah, unless you have more to say on it, we can get into some of our other topics.
No, we can move on.
All right. So our next topic is on mixing up public and private keys and OpenID Connect deployments. And for the most part, what's on the tin is what it's about. That it's easy to mix up the formats because the private and public keys, where they're stored in JSON, are basically the same. Like they look very, very similar, with the exception of one private parameter being included for private keys. And because of that, it can make it very easy to mix them up. They also talk about some other key problems, things like using keys that are too short. So they use like RSA 512, which has been breakable for a while. Other things that are fairly common, like using example or default keys and not, changing them to secure other keys. So just kind of like crypto problems in general with OpenID Connect, which I haven't really thought of for looking at
Yeah,
with like the
when
provisioning on that.
when we were talking about this a little bit before the episode, you had asked us if I had, some experience on like looking for that, and I made the comment like, no, I hadn't even thought about looking for that. Um, like I've looked at like JWT, or sorry, the JSON web keys, like seen the file there, and like I haven't. Maybe I'd have queued on like, oh, was that there? But I feel like most of the time I probably will have just looked to see like, okay, that looks like the key good enough, and like move on. Or maybe if I were trying to do like it depends on what the audit was, and I've never need to actually audit a OAuth provider. That's never been in scope. Like when I did the consulting and now doing the phone research, like that's not part of it at all. So it's not really been a part of my project. So could just have missed it in that sense too, but not having to look at it. But I thought it was an interesting to just, be aware of. This would be super easy to like, if Burp isn't already doing this, adding a quick plugin to scan for like the extra fields in a key to just take a look at, because yeah, extra fields in a key should always maybe raise a flag and be like, huh, why is that there? And then yeah, you can recognize like, oh, that is like the encryption part or whatever. Being able to recognize some of that,
Well,
just
see,
by taking a look. Go ahead.
part of the problem with that though is especially true with ECDSA. If you're not intimately familiar with what these parameters are and what they do, like a lot of people probably just read this and be like, okay, sure. Like I don't,
That's true.
I don't know necessarily what the D parameter even does in ecliptic curve. I know it's supposed to be secret, but like, some people looking may not even know that implication. It's just looking at crypto parameters, unless you're like searching up the documentation and trying to look at what they mean, the implications of them being there or not are not obvious at all.
Yeah, but that's where I kind of mentioned where if you're queued up on just the fact that if like something gives you the alert that there are extra fields, not necessarily telling you this is specifically this, But like if you know what the algorithm is, you could go take a look and see like, oh, the public key for a curve should only have the X and Y point on the curve. It shouldn't include anything else. So then you can just look like, what is the extra information here? And like figure it out what it means without actually needing that to be built into the actual checker. So the checker would end up alerting you maybe on some benign things like, oh, they include a name in it or something. But
Yeah.
that's super easy for a human to just be like, okay, fine. You can kind of explain a lot of things away pretty quickly.
Mhm.
Yeah, it feels like the sort of thing that could be caught very easily with a scan now that you're kind of aware of it and taking a look for it. A lot of times, like, it's probably not going to find you anything too useful. They did say here that they did find several hosts with with the private key being out there here. I think they had 9 hosts. Yes,
It was
including
like
like, yeah, Stack Overflow teams, uh Uber internal, FIS global. Those 3 all appear to use the service provided by Stack Overflow, so maybe put the blame on Stack Overflow there. But yeah, I don't know, just one of those things that, okay, I kind of understand, because JSON, the format of JSON itself is just like, or especially parsing JSON, a lot of times you're just going to look and be like, I need this field, this field, this field, and if there are extra fields, your code just doesn't care. It doesn't like error out because there are extra fields. It's just like, whatever, I'm not parsing those fields, and like, you're good to go.
Yeah, by design, it's not a strict check on the inputs and whatever. Yeah.
Yeah, so I think it's pretty easy to kind of end up in this case, especially because like in your public and private keys, like generally speaking, you're not going to like rename the X and Y coordinate that you're using to be something like something else in your private key. Like, no, it's still those. You just have the other information you need to actually derive the secret, or like the encrypted information that other people wouldn't. So yeah, I totally get how this is happening, or how it could happen. But yeah, it's not really something I'd considered looking for. It is maybe one of those things that if you looked, you'd be like, oh, that is just screwed up. But yeah, I don't know. It's interesting. I thought we'd call it out here.
Yeah, and as we always tend to say with crypto issues, it's very easy to have them and just not notice. And
It's
with the particular case of leaking private keys, like the impact, depending on the context, can be huge, depending on what it's used for. So
Yeah, well, with signing keys, it kind of matters here.
yeah, yeah, exactly. But yeah, like I said, it's a fairly like high level understandable issue. There's not much to it, but yeah, it's something to be aware of and keep an eye out for. So with that said, we can get into some of our other web issues. So our next topic is from Asset Note researchers on a vulnerability in Palo Alto's PanOS, which led to auth bypass in the management interface. And the process here is a little bit complicated, as it ultimately comes down to sort of a parsing differential with nginx versus Apache. So I'll let Z get into the details.
Yeah, I didn't actually realize that Acid Node was acquired by the
Neither did
search
I. I
giant.
had to
Yeah.
look into that when I was doing prep work for this topic. I was like, wait a minute, they say Asset Note researchers in the opening statement, but then it's not on Asset Note's site. It threw me a little bit.
Yeah. There is this rather interesting auth system that's been set up in PanOS that I definitely don't like it. Basically, the gist of the architecture is Nginx comes in, takes the initial request, that's incoming requests come into Nginx. Nginx just sets a bunch of headers. And then pass it on to Apache, which will pass it on to PHP. And yeah, again, Spectre and I kind of talked about these a little bit beforehand, and we'll mention like having Nginx, Apache, PHP might sound a little bit weird, but Apache and PHP like go together really well. Um, Very common to see PHP running on Apache. I don't know if it's still the case in terms of performance, but I know for a while Apache just had really good performance with like their fast CGI or whatever they were doing to run PHP. So, you'd put Nginx because it had better like cache performance and serving all the static files, so that would be in front. Then you'd pass things on to Apache to actually, manage all the PHP instances because it was better there. So that could kind of be why they have this. I think today, if you heard that setup, if you don't work with PHP a bunch, it's like, why are you using 2 completely different web servers? But anyway, yes. So nginx goes and says like sets one header in particular, this xpan dash or x dash pan dash auth check on, and that controls whether or not the PHP application is going to do an auth check. In fairness, like it is being set by nginx, so you can't just like control it and change it to off and like pass that through. But it's still like it is the fact that it's coming through these systems and like it's just nginx that's telling it like, oh yeah, you need an auth check here, not here, kind of leaves some room for some issues. And in fact, what they kind of come up here with is a path confusion, where nginx reads one path and thinks, oh, you don't need the auth check for this, whereas Apache parses it down before passing into PHP, gets it to a different path that usually would have an auth check, but because that header says auth check off, it just passes it on through. And part of this is probably like, I don't know for sure, but API access, like they would perform that at a front end, turn the auth check off in the code. But I really don't, I do think it should exist at a different layer than, I don't know. So having auth at like a reverse proxy layer, it's something I do a lot with any sort of zero trust system, is front end's just going to enforce auth. And so I kind of understand it. Anyway, jumping onto this issue, core problem just came down to when you make a request to slash any path that started with /unauth/, that would basically get this pan auth check off. It would set the variable, but ultimately that leads to the header being set to off when you ask unauth. So nginx sees that request, comes into unauth, turns the header off, or it's going to the logout URL would do the same. And so you'd have that request, but then when Apache gets this, it's going to do some parsing on its own. And in addition to that parsing, it also has some rewrites going on. Turns on the rewrite engine, does a rewrite here on whatever page, has a few rewrites that they kind of show here. But ultimately, when it's doing the rewrites, it's also going to be resolving URL encoded characters. And so what they basically found was they could double encode, or they can come up with a request like this, which has /unauth/. So when nginx sees this, it's going to see it as unauth. It's going to say we don't need the auth check. Apache gets this. It sees it's going to unauth, going to this other thing that it's now going to decode the .. in there, or well, part of it at least. It's going to decode it, ultimately leading it to be like, okay, let's reverse this path traversal because it's .. so we don't need unauth anymore, sending the request over to the PHP ZTP gate endpoint here. But the header still remains. So with that little confusion with regards to the path, or at least ultimately getting to the path, a little bit of complexity around like the double encoding there, but it's still like effectively what's going on is just that URL rewrite.
Yeah, and it's one of those things where, because that Apache rewrite rule is basically just one of those quality of life things where it's like, if it has .html or some other extension, it'll redirect it, so you don't have to have the exact URL. It's just kind of one of those nice things, and you don't really think about that having security implications, but in this case it does, because of that ability to reprocess the requests and do that additional decoding. Yeah, it's very fun how you have that smuggling aspect because of the differential there.
Yeah, and one of the cases with the rewrite rules here was they're rewriting it to send out or serve the .gz file. So in that case, they're just skipping on the compression and serving it like getting it compressed from the file system. So it's also kind of done for performance, not just that is kind of a quality of life aspect too. But yeah, so ultimately it just comes down to the path traversal because of the mixing of systems. One ends up decoding everything and resolves the path incorrectly before passing it on to PHP. It's a fun bug. I guess this is tied into Orange's research, which I think we touched on during one of the prior episodes where we were just talking about the not the OWASP top 10, Portswinger's top 10 research for the last year. It's the confusions in Apache were part of that. So, we're kind of getting, without covering that post, we're kind of getting a little bit I guess related. They call it out here. If you've been following Orange's research, you may be suspicious of the rewrite rules. So yeah,
Yeah,
as a
you have
bug,
that backlink. Yeah.
yeah, as a bug, I think it's kind of a fun one to be aware of. The whole Auth system is definitely just suspicious in general because when you're making those decisions super early on in the chain, just the idea that nothing's ever going to change later on just feels like a very bad assumption to make.
A little brittle. Yeah.
Yeah. And speaking of brittle, I'm pretty sure we've seen other brittle stuff in PanOS in past episodes.
Yeah, we I don't know if it's just because it's such a sought after target, because I think it is a target that in the wild, attackers in the wild do target fairly frequently. But the Palo Alto stuff in particular, we seem to see a lot of, whether it's from Asset Note or Talos, I think covered quite a bit of it
Oh
too.
yeah, they have.
Yeah, so it's funny how much it seems to come up, but
Yeah,
yeah,
I mean
this bug in
it's
particular, it's a little bit, it's not like a super straightforward issue. There is some complexity in the the whole setup, and you have to look at it as a whole and not just one specific component to understand it.
yeah, exploitation's very straightforward, but the actual process of how this came about does take, as you said, takes like multiple systems going on here. It's not just the PHP code having a mistake. In
Yeah.
fact, the PHP code is kind of doing what it's supposed to. It's everything together, the integration that leads to the issue. In terms of like PanOS, like Palo Alto stuff is well used and respected, like firewalls and all the
Yeah.
networking devices. So it makes sense that it's commonly seen and targeted because it's running on the edge a lot of times. I mean, maybe not the management interface being accessible on the edge, but like it's there.
And continuing the theme of somewhat complex path traversals and attack chains using them, we have a post by Viter Falco on a client-side path traversal to XSS chain in an undisclosed target. I'll let Z get into it.
Yeah, and this one is another pretty fun chain going on here. It starts off with the pretty simple client-side path traversal. You make a request to slash categories here as their example. You might have just normal request comes into the page slash categories slash number. Ultimately, then the API generates a URL to this API, or well, the JavaScript on the page generates a request to slash API v2 category slash whatever that number was from the URL .json. And that JSON file is kind of interesting because several fields in there would be passed directly onto the page using inner HTML, so it was kind of like a trusted file. And that number could be, another path. Like it didn't really do a lot of validation. So if you sent like a slash URL and code with that, of course, in there, it would take that as part of the URL when it generated the API endpoint and send it along, allowing you to hit other endpoints beyond just that expected JSON file. Part of the post includes like their thing, what they might have been looking for, but what they're looking for, like they talk about here, like with an open redirect, we could easily like craft this and point off to a malicious thing, but they didn't have an open redirect. But they do kind of include that information about what they were looking for, what their thought process was. So again, you get a little bit of insight onto the methodology with this post. So I'm going to skip over those details, but if you do want that, they are included in the actual post. So what they ended up finding was that part of the API, part of the actual product had pro memberships. Buy this pro membership, and you can set up digital files that you can sell. And for that, there's the API marketplace endpoint that would serve the files and basically make this request to API slash marketplace files and then file number for it, unrelated to category number. But that would generate a pre-signed S3 URL. That URL would normally just come out in a 200 response, but they did discover that you could include a redirect equals true parameter, and then it would just do like a 302 redirect to whatever that file was. So in that case, you have a pro membership, so you could upload files, upload your malicious file, and then you have the API marketplace where you can get a redirect to happen to this file along with that client-side path traversal. You'd be able to basically use client-side path traversal with a custom category number there to point it over to this marketplace endpoint. The marketplace endpoint will redirect you to the attacker-controlled file. However, they had to deal with cores. They weren't able to just get that file working, and they also had to deal with permissions, actually. Kind of two things with that. One is the fact that, you create these files to be purchased. So, when you make the request to the API marketplace, it's checking your account. Are you allowed to access this file? So, basically, under like a trivial exploitation, like assuming it just worked, it would basically be an attack where somebody has to purchase their attack, which I guess I could imagine it, but it does make the attack kind of funny if somebody has to pay for the privilege of being attacked. So yeah, they had to figure out a way around the two things there. One is this auth issue, and the other thing is just cores in general. Because what they found was when they requested this file, it wouldn't have like an X control allow origin and like a star header, for example. When it basically wouldn't allow cross origin requests to come in. And they found that this actually had to do with the caching of CloudFront, and which was running in front of the S3. So they had S3, CloudFront in front of it, and the first request into the CloudFront would kind of determine what the cache response looked like. So what they discovered was that if after you upload a file, you click the download link, it would make a request over to that file, and it would not include an origin header. Which means CloudFront, when it cached the file, would not include an X control origin header in the response. However, if you just left this off and you didn't actually click that download link and like test it after you upload it, instead you just tried to access it through the client-side path traversal immediately, when that request came through, would be a cross-origin request. It wouldn't be a full navigation or whatever. It would make that request. It would include an origin, and so CloudFront would just respond with a allow origin star, or kind of wildcard allowing it. So it would get cached with that. So then they could now use it as part of their client-side path traversal. They just need to deal with the cores first. So the caching issue, I think, is just interesting because it's not easy to recognize that would be the issue. I don't know how they actually figured it out. Like, my guess would be they might have seen some requests coming with and without and just had to figure out what the difference was, like how that happened. Like, some files serve through S3, unless it's only marketplace files, and they might not have been able to see that. But
I feel like that might just be something that you have in mind more if you deal with caching a lot, because I feel like we've covered similar things before when it comes to caching and the behaviors being different in that way.
But this just comes down to like first request being the one that gets cached, and like that something will cause a request that doesn't include, or that does include, the header. How they know that some part of the application will make that request properly. Although I guess, like, at the same time, you could make that manually without necessarily even needing to do it through the CSPT. Sorry, without needing to do it through the client-side path traversal. You'd be able to make that request manually and include the origin header and get it cached with that allow origin response. So maybe that's also just an extra step there that isn't, well, yeah. Either way, I mean, ultimately, they get a cache, they get the cache response to include that header, so they can now use it with their attack, but they're still needing to deal with the authentication. Otherwise, this is just a self-attack, or it is somebody literally paying for the privilege of being attacked by you. Which, I mean, doesn't feel like, well, I guess it's not even that, because somebody would buy the file and it would just like, what is this? It wouldn't even have the access, because you still need the rest of the attack to actually like trigger it. Anyway, the way they dealt with that, I think, is the coolest part of their attack here, and deals with something we talked about somewhat recently when it comes to setting a cookie to a specific path, so that, you know, part of the request comes through being authenticated with one cookie, whereas the rest is kind of another. So they kind of joined a few ideas here. One, they had a cross-site request forgery that was a login-based CSRF to log in on through OAuth, so they could force a victim to log in with the attacker's account. So it's still kind of self-XSS, but their CSRF ends up ends up logging them in. So once they did that, they would get them logged in with their accounts, so kind of self-XSS. The actual XSS would then launch because they're able to access that file, so it resolves the S3 link, has the appropriate header, they get the XS running. That would then do a cookie bombing attack where they basically make a bunch of cookies, so there's too many. Ultimately, the header payload gets rejected by the server, and they get treated as they're being logged out. So the user then logs in again. They trigger and they get that login. So they'll also open a login page for the user to help them log in again after they've just done this attack to log them out. And with that, they'll set it so the redirect of that login will end up going to their attack again. Only this time, because of the cookie bomb, they also end up setting their session cookie for the API/marketplace/files endpoint or path specifically, set that cookie to be their attacker token, like their control token, so they'd still be logged in on the attacker's account on there. So when it redirects to that client-side path traversal again after they log in legitimately, the XSS will run, and most of those requests, except for that one marketplace file request, will be on the on the victim's account now. So they had like a full-scale XSS from what kind of started off as a self-XSS or fairly limited, unlikely user interaction XSS. So I thought that was like a really cool strategy and really cool to see that done kind of for real instead of just like talking about like that sort of attack. Said I think we covered a similar thing like very recently, might have been in the Portswigger top 10 where we had the cookie thing, or it might have been something else. I don't remember for sure, but I do remember seeing that technique very recently.
The aspect that I really liked about this is abusing the paid like pro membership functionality for the arbitrary file upload. Just because one thing that stuck with me from early on when I was getting into security research is that whole idea of trying to identify a good attack surface. And one of the best tips or whatever things that you always want to think about is the attack surface that people aren't necessarily looking at for one reason or another, whether it's accessibility functionality that isn't being used by a lot of people or there's some other circumstance. Those tend to be the attack surfaces that yield the most. And of course, when you're talking about pro memberships and stuff, you're going to have researchers that don't want to do that for one reason or another. Maybe they think it's not it limits the impact too much, and so they don't look at it for that reason. Or it might be something like what they call out in this post, where they don't want to make that initial investment because they're not sure if it's going to pay off. However, in their experience, most of the time it does pay off, specifically because it doesn't have as many people looking at it. And I think that's a great call out. It just, like I said, it strikes back to something that I always keep in my mind from a long time ago when it comes to profiling your attack surface.
Yeah, that is something they kind of talk about in their section. They literally call it just paying for more attack surface.
Yeah. And it's great. You don't really see that called out very often at all. So
no, that's good advice. Like premium functionality in general tends to be weaker. In a similar vein, admin functionality tends to be weaker. Of course,
that one we can't
just you can't just usually pay for I mean, maybe you can bribe for admin functionality, but you're probably not getting a bounty if you bribe your way in. But yeah, it is a good shout out in terms of the attack surface. I think a lot of hunters are somewhat aware of that, but if you're not, like, yeah, I'd say a lot of times there's value in paying for the premium. It's going to depend on the thing. Like, you probably don't want to pay $10,000 for this, but most services that you're going to be testing on probably don't have a pro membership that's that expensive either.
That's like enterprise, yeah.
Yeah.
So we do have some more Apple vulnerabilities this week. This is a post by Kanji. It's the last part of a 3-part blog series on vulns and macOS. The first 2 posts go into some background and vulnerabilities with a particular focus on the disk arbitration daemon. Those are from November and December of last year, and the issues are a little bit more like your typical sort of path traversal kind of things from what I could see. This one is a little bit more interesting, and it's a vulnerability in the storagekit daemon. It can allow root privilege escalation, though there are some conditions around that. So the basis for this bug is the fact that when you go to mount a disk to a directory, you use the diskutil command. That command calls into the storagekit daemon, which in turn calls into the diskarbitrationd daemon, and the diskarbitrationd daemon performs a lot of the sandbox checking and the privilege verification. But the thing is, because you have that additional step, um, the diskarbitrationd daemon sees the caller as root when it comes from storagekit, rather than the actual user that's trying to mount. And because of this, where storagekit is the first entry point that runs as root, it also has to do that privilege verification and make sure that the caller has the right permissions. The problem is here, it doesn't. So you could mount a volume over top of a privileged directory, such as etc cups, to hijack like the configuration files in this case and escalate to root by using the logging functionality. Now, there is a bit of a caveat there. Because disk arbitration expects the volume to be owned by the caller, which in this case would be root, you do need a root owned volume to do this. So they state you could do this as a regular admin user. And unlike some other operating systems, macOS does have a privilege separation or a privilege boundary between admin and root, but you can't do this from completely untrusted or something. And as was the case the last time we talked about an Apple topic, this story also had some incomplete fixes by Apple. They tried adding a check into the storagekit daemon to check if the user has privileges to mount over the given directory, and if it needed privileges, it would prompt for them. The problem was that that was vulnerable to a time of check time of use and could be exploited with symlinks. They never go away. They're gonna pop up all the time when you're
Yeah,
talking about these issues.
I thought it was interesting though with this one that the disk arbitration, I believe. Let me see if I can find it here. So they did manage to get around it, but disk arbitration itself specifically did use the do not follow symbolic link option. The reason it still worked was because of this layer in between that's used for the IPC communication with disk arbitration. That would do the resolving for you before disk arbitration got to, it would resolve it first.
Yeah. So again, you have kind of that interplay between different systems causing problems.
Yeah.
Uh,
Yeah, and I really like that just with the initial issue. The layered approach where it's like disk arbitration is like, well, let's check and make sure the right thing's calling us and has permissions. Somebody else is just like, well, let's use this already nicely existing interface as like the API, maybe not aware of like the fact that they now need to take priority on the checks or whatever. Because I can't see that. I have no idea what's going on internal with Apple and like the thought process, but where somebody writes an interface and it's even like does all the security, does all these checks. And then it's like, well, I'm just going to use that interface somebody else wrote, kind of wrapping it without understanding the fact that it's using like the caller as the basis rather than some other piece of information as the basis for those checks. Like I can kind of see where this issue arises from and just having those layers in between.
yeah, 100%. And as we've said a lot lately, when you get to the file system stuff, it adds so many complications to the setups. And like I said, the impact is a little bit low there because you're ultimately getting like an admin to root privesk, but that is still valuable when you're talking about Apple products because they have a lot of defense in depth and like nested permissions in that way. So getting admin isn't the end of the story if you want to, compromise the whole system or whatever.
Yeah, it's still a fun bug regardless.
Yeah. So we also have a topic on that involves some hardware hacking, which we haven't really gone into too much recently. So it's a post by PT Swarm on 3 attacks that could be used to bypass readout protection on GD32 microcontrollers. And I'm going to get into some background before touching on the attacks. So these GD32s, they're used in a bunch of different places. They're used in industrial control systems, alarms, consumer devices, whatever. There's a lot of different areas that they can be leveraged in. And to secure the device, there's 3 levels of readout protection that are provided to disable the debugging functionalities in the bootloader. So you have level 0, where there's no protection. They can be programmed and debugged. They're mostly meant for developers to use and work off of. You have level 1, which blocks access to flash memory from the debugger, though the contents in SRAM are still accessible. SRAM there just being like static RAM. It's the bit of RAM that the bootloader uses. You can degrade level 1 protection back to level 0, but doing so erases the flash contents. That way, you can't just downgrade it and gain access to what's supposed to be secured content. Level 2, which is only provided on some of the MCUs, the debug interface is disabled outright. You can't program the bootloader or access any debugging functionalities, and it also can't be downgraded to the previous levels. So this security level is set in a secure area of the flash, which, as we've kind of gotten into in the higher protection levels than 0, you can't just gain arbitrary write access to the flash. And flash is also kind of difficult to get at from the hardware unless there's a protocol exposed, because uh, how flash storage works is just really kind of crazy and difficult to get introspection into. So getting into the first vulnerability, they found that on GD32 devices, even in level 2 readout protection state, the software debug interface via JTAG was enabled during reset state, and then it was turned off at a later point. So of course, there's a race condition there, where during reset state, you could access debugging functionality even though it shouldn't be reachable on that device. This was a little bit limited because this was happening during reset. So if you use that functionality to try to write into the bootloader or whatever, it wasn't very useful because those changes would be lost shortly after. And in order to access debugging, they had to enable the debug power domain. And when that's done, they have an additional locking mechanism where once the debug power domain is flipped on, the flash memory is locked and it can't be read directly by the firmware. They mostly use this to pull data out of SRAM and exfil code and data that they could coerce the bootloader to load from flash. But on its own, their initial exploration with that first vulnerability was a bit limited. The second attack gets around the flash memory locking mechanism to make it more useful. And the basis for that is the lock is attached to the control register bit for enabling the debug power domain. And so if they use their brief window of access to load controlled firmware that waits for a signal, and then upon receiving that signal would dump the flash contents, they can set up this scenario where they load the firmware, they get it to wait, they flip off the debug power domain, and then they send the signal and dump the flash contents over some other communication channel like serial. So just kind of using their ability to establish a foothold to, get a state where they could still read the boot or the flash contents. The last attack starts off with the fact that they tried to do some voltage glitching on the reading of the config info from the flash, including that readout protection state. And their thought process was, if we glitch that and get that to read an incorrect value or whatever, they can bypass the protection. Didn't really end up paying off, unfortunately. They just couldn't really get their glitch parameters to work out. So they went back to their initial access from the first vuln with the race, and they found that even though the flash memory lock prevented reading the flash directly from the from the microcontroller, they could access the contents via the DMA engine. So all they had to do was use their initial access, write some firmware that initialized DMA and UART, and then send DMA requests to read out the flash contents. So just sort of abusing the fact that even though you can't directly read from the firmware, you can use this other hardware block to get around the permission system there, sort of circumvent that protection. So yeah, I mean, even though there's some hardware involved here, the issues are fairly understandable. They're fairly high level problems, mainly coming, a lot of them tie back to that fact that you can access the debugging during a brief window of that reset state, which you can kind of snowball into exploiting some other hairline fractures to ultimately bypass the protection completely. So it's very cool. You got that issue chaining aspect of it. So yeah, I think it's a really cool attack chain.
Yeah, it's a cool chain, and I mean, dealing with the hardware level. The disclosure timeline is a bit long. I mean, it's hardware, so it's going to be long. There's always going to be the delay. But this was first emailed over to their CERT uh, on March 30th, 2023. So it's nearly been 2 years since it was first disclosed.
Oh
Less than
yeah,
a
I didn't even
month.
catch on to that. That's
Yeah.
quite a while.
Even the last entry on this list was a year ago, January 6th, 2024, with just vendor feedback update, plan to fix these on new silicon. So yeah, it's, I don't know. I mean, granted, they maybe just took some time for themselves and were like, "Oh, got to write this up immediately." But yeah,
Yeah.
there isn't. I guess there isn't a lot of feedback, and they do mention here that they did get this information via CERT coming back to them, so they probably didn't communicate directly.
Yeah, I will say kind of like what you hinted at there. I don't have a ton of insight into like the hardware space and the timelines that are done there, but the bit I've heard where you kind of expect your timeline on software bug fixes to be in terms of months, like, like 90 days or whatever, so like days or weeks or whatever. On in hardware it is typically years. Because you do kind of have that, factory lag where fixing it, like, it's a lot harder to deploy the fixes on a scale.
Yeah, it's harder
Um,
to fix. It's harder to fix hardware.
yeah,
Like
especially at scale.
yeah,
So yeah, not too surprising, but yeah, that's worth calling out. I didn't even really check out the disclosure timeline section, but it's worth calling out. But yeah, so a fairly interesting attack chain. I'm not totally sure how practical it is. Like, you would kind of need that. You would need that physical access to pull off these attacks. You need to have the timing perfect and be able to hit it in the reset state. That said, when you're talking about things like industrial control systems and stuff, that is still a reasonable thing to have in your threat modeling. So,
yeah. I mean, the
uh,
device has the protection against this sort of attack, or tries to. So, like,
exactly.
it's part
Yeah.
of the threat model.
Yeah. But yeah, you would still need that physical access. Not something you could really do remotely or anything. But still very cool.
Yeah, I mean, most hardware attacks aren't remote accessible, so
True. All right, so that's most of the topics we have for the episode. We do have a shout out that I will let Z get into, and then we'll wrap it up.
yeah, I had one shout out here. It's attempted research in PHP class pollution. And the conclusion here is kind of what you'd expect. Just give, at least if you have worked with PHP a bunch, you kind of know some of this. With class pollution, the idea, especially in like JavaScript, where it originated, there's been a little bit of research into it with Python. While you do have like a standard class, you don't have something that has properties you can just overwrite. Like it's literally, I think, called STD class or STD object. I forget. Yeah, class. I see it here in the post. So you kind of have that. So like unexpected, they didn't have a lot of success with like having some that genuinely reflects class pollution like you have in JavaScript. But I really appreciate them putting the research out here and actually just taking a look. Like, hey, there's this vulnerability on here and here. How does that work in other languages? What are the impacts there? And so they take a look. How does it work? Why doesn't it work? And what's the impact there? And just they had the question, they went and answered it for themselves. And I think that's a really important just step in learning about vuln research and learning about exploitation is just answering your own questions when it's like, why does or doesn't this work? Just go and take a deep look, because as you're doing this, you also end up learning a lot, and like that ends up helping you in the long run. Ultimately, yeah, it wasn't a successful project where they did like, yeah, this is this major issue that everybody's ignoring in PHP. Ultimately, they do kind of say like, yeah, you can overwrite, like in some cases overwrite objects properties if they do the same sort of JSON merging that would happen in JavaScript. But that also isn't, I don't think they really called out in here, but that isn't really the paradigm that's used in PHP also to like do that merge. Like it does happen from time to time, but not really the paradigm that's commonly seen. Can exist. There are, especially in things that like to use the magic functions that will like rewrite attribute rights into an array. Like suddenly you do actually get that. So like does exist in places where it could be useful. But yeah, I just appreciate the fact they put it out. So I want to give it a shout out. Unsuccessful, but still I think valuable to do the research and then put it out there so other people can learn from it.
For sure. And with that said, that's all the topics we have for today. So as always, thanks goes out to everyone who tuned in, and we will see you next time.